Welcome to ClickMyProject.com. Now we discuss about the product for a fault tolerant technique using quadrat logic and quadrat transistors. Next we see the abstract for the product. Advances in fabrication technology have made to integrated circuits more prone to manufacturing variations, aging and or soft errors. This is of significant concern in many safety critical applications such as medical devices and aerospace applications. Fault tolerance has become an integral part of digital circuits and system designs. Hardware redundant techniques have been investigated in mitigating the effect of failures. Most common technique is triple modular frequency as a particular case of n-double modular redundancy. Quadrat logic is a fault-tolerant technique in which quadrat number of gates are connected in a systematic manner such that the alternating layers of logic gets correct a single is one of two layers. In this brief and novel tolerant technique is proposed by combining QL with QT implement at the last layer of the circuit. In this technique, quadrat transistors replace every transistor in the gates that produce the circuit output, whereas quadrat logic is implement for the remaining circuits. The implement is therefore referred to as a quadrat logic with quadrat transistors technique and is the take advantage of the gates and simultaneously serves as the vector or arbiter. Advances in CMOS technology have made two digital circuits and systems very sensitive to manufacturing variations, aging and or soft errors, and fault tolerant technique using hardware redundancy have been extensively investigated for improving reliability. Quadrat logic is introven redundant logic technique that correct the errors in switching them from the critical to subcritical status. However, the quadrat transistors cannot correct the error is the last, but this method to correct the error, direct the error and corrected also. Next, we see the processing diagram for the project. First, the input data bits to apply to the 2:1 mux architecture. This mux to select based on the normal mode test mode selection logic and to passing the input data bit or normal mode input data memory output bits. This function first to activate the normal mode function and the input data bit to passing to the mux architecture. This mux architecture passing from the CUT circuit under test functions. This circuit under test function is used to whatever circuit we analyze, that circuit placed in the circuit under test platform. We implement the S9234 benchmark circuit for our testing process, then to identify the fault in the output data bits and to correct the output data bits. The output to be first saved in the normal mode to passing the recorded value. In this recorded value based on the expected signature, and what are the input to be compared and testing with our S9234. So the input also saved to the normal mode input memory. Whenever we activate the test mode, we get it to the normal mode memory for one by one and to passing to the circuit under test operations. This circuit under test operation to perform the S9234 benchmark circuit and to produce the output value. The normal mode function to create the golden signature for the output values and the test mode activation to create the present signature for the output. This signature to compare to these two things and to create the sign creations, then to produce the output data bits for the fault detection methodology, then to identify the XOR function variation whenever fault to be present in these two things and to produce the one for the XOR output whenever the one to be output for, so just to invert the golden signature for and present output. This function to perform the error detection and correction for overall S9234 benchmark circuit testing process. Finally, we see the output for the product. These are the test function for Xilinx IC project. just double click the IC project file, then to open the software file, then we go to the simulation process, then select and simulate BM model to be run. This process to run what are the input to be passing our architectures and to present and output and error detection, error corrections process, all the things to be displayed in the simulation functions. Just to open the ISIM project files, then to apply the data files for our overall architecture, then to apply the force clock functions for 0 and 1 and the 1000 nanoseconds period for overall architectures and overall architecture, then to apply and to passing to the any one of the data fits for output functions, then to set the normal mode function to initially set the 0, then to passing these output for the overall architecture function, then to set any one of the output to the present memory signatures to compare with all the things and to passing the overall output functions for required testing architecture, then to passing output and storage for the overall output, then to then 3 output for the output memory to be stored in the golden signature, then to set the test mode activation, then to compare with these two things and to produce the output data bits for overall architecture. These are the final process for our overall architecture function. These are the final output for our required output data bits for every updation function. This is the error detection and correction operation for overall simulation purpose. Then go to the implementation process and to passing the RTL diagram. This RTL diagram to represents what are the input and logical function to be present in overall architecture functions. Then to open the RTL diagrammatic representation for IC diagrammatic representation for overall architecture. These are the IC diagrammatic representation. Then we go to the device utilization summary for overall architecture area complexity. Then we go to the synthesis report and to analyze the timing summary for required our architecture based process. How much time to process with overall architecture and how much speed to be implemented in our running process, and latency time calculation for testing with the error detection correction performance for overall quad transistor based testing operations. This is the final architecture for overall output.